Hello, get ready with pen and paper as we solve the question number 533 to 543. And in the next video, we will learn polynomials and theory of equations. So I'll say that what I always say, that is when I'm stating the problem, pause the video, solve the problem yourself. If you cannot attempt the problem yourself, then look at the solution. Do not spend more than 15 minutes on one problem. Okay, if you get stuck, move on to the next problem if you can't do it in 15 minutes. And look at the solution if it is not solvable within 15 minutes. Use the pause button to pause the video, write down stuff, and then if you can't do it, look at the solution. The link to download the PDF will be in description below, and I will show you how we can download the PDF at the end of the video. So without further ado, let's get started. Question 533 says that for what values of k, both the roots of the equations x square plus 2k minus 3 into x plus 9 is equal to 0 lie between minus 6 and 1. So we let alpha beta to be the root of given equation. Because roots are real, the discriminant would be greater than or equal to 0. So that implies b square minus 4ac. Okay, there. So yeah, b square minus 4ac. So we have k minus 3 whole square minus 9 greater than or equal to 0. Now, if you solve this, you will arrive at k less than or equal to 0 and k greater than or equal to 6. Now, f minus 6, if you compute to be greater than 0, it is minus 12. K minus 3 plus 45 greater than 0. That implies k is less than 27 by 4. Now, f of 1 is to be greater than 0. So 10 plus 2 into k minus 3 greater than 0. That means k should be greater than minus 2. And we have the 533. The roots lie between minus 6 and 1. So we have alpha plus beta by 2 should be greater than minus 6. That is k less than 9. And 1 should be greater than alpha plus beta by 2. That is k greater than 2. So we combine all the conditions. We arrive at 6 should be less than or equal to k should be less than or equal to 6.75. Very straightforward question. Question 534 says that at what values of m is one of the roots of the equation 2m plus 1 x square minus mx plus m minus 2 is equal to 0 is greater than unity and the other smaller than unity. So one root should be greater than 1 and the other should be smaller than 1. You have to find the value of m. So we let alpha beta to be the roots of equation. When 2m plus 1, this term, coefficient of x square, when 2m plus 1 less than 0, m is less than minus half. Also, we let alpha less than 1 less than beta. So f of 1 would be greater than 0. Okay. What this implies that, so we assume that the coefficient of x square is negative and alpha, the root 1 lies between alpha and beta. So clearly f of 1 would be greater than 0. So 2m plus 1 minus m plus m minus 2 greater than 0, which is m greater than half. Now that is a contradiction because our premise was that m should be less than minus 1 by 2, but it is coming as greater than half. So definitely m is greater than minus half. M cannot be equal to minus half, otherwise the equation will no longer remain quadratic equation. This term will vanish if m becomes minus half. So m is greater than, there should be an m here. Let me note that down. So question 534. Give me a second. So m should be greater than minus half. So f of 1 would be less than 0 because now the coefficient of x square is becoming positive and roots are root 1 will lie between the roots. So from this we get m is less than half. So combining the condition that m is greater than minus half and m less than half, we arrive at the solution. Question 535 says that find the value of m for which both the roots of the equation x square minus 2mx plus m square minus 1 is equal to 0 lie between minus 2 and 4. So roots lie between minus 2 and 4, real roots. So we let alpha beta to be the root such that alpha is less than or equal to beta. Now, first we compute discriminant to be greater than 0 because alpha beta are real. So that gives us 4m square minus 4 into m square minus 1 greater than 0. This implies that m lies between minus infinity to infinity. That is, it is true for all real values of m because 4m square simply gets cancelled, 1 greater than 0. Now we compute f minus 2, which should be greater than 0. Okay. Why it should be greater than 0 is because roots are outside the range. Okay, it is on one side of it. So from this we get, by putting x is equal to minus 2, we get m to be less than minus 3 and m greater than minus 1. Similarly, f of 4 should be greater than 0. So we get from this m less than 3 and m greater than 5. Now we compute the sum of roots divided by 2. We get from this m greater than minus 2, and for 4 we get m less than 4. So we combine all this, we get the equation as minus 1 less than m less than 3. Now question 536 says that find the values of a for which the inequality x square plus ax plus a square plus 6a less than 0 is satisfied for all x in 1 and 2. That is, the roots lie between 1 and 2. This is an open interval. So we have to find the value of a. So the discriminant would be less than 0. Hang on, quotient of x square is positive, okay, and it has to be less than 0. So discriminant is not less than or equal to 0. Now, the given inequation will hold if d greater than 0. Now, the given inequality also holds if roots, let them be alpha and beta, lie between 1 and 2. So f1 should be less than or equal to 0. That is, that gives us this value, this equation, and then we solve, we get to a range for a. And f2 should be also less than 0. We substitute, we get a square plus 8a plus 4 less than or equal to 0. We get another range for a. Okay, so we have two ranges, we combine them and we get this result. Alright, very easy question. Question 537 says that find the value of the parameter a for which there is at least one x satisfying the condition x square plus 1 minus 3a by 2 into x plus a square by 2 minus a by 2 less than 0 for x is equal to a square minus half. So we have to find the value of parameter. Now we are given that x is equal to a square minus half. So we substitute that and we simplify, we get this equation and we simplify it further. So I will not talk about simplification. I will not read out the formulas. So finally you arrive at this. Okay. Now this will be always greater than 0 for all a. Okay. Why? Because a square minus 2a plus 1 is a minus 1 whole square. So the entire equation is a square plus a minus 1 whole square. That is always greater than or equal to 0 for all x. So a minus 1 and 2a plus 1 product should be negative. So this can happen only if a lies between minus half and 1, which are the roots of this quadratic equation formed by these two. Very straightforward question. Question 538 says that find all values of the parameter a for which the inequality 4 to the power x minus a into 2 to the power x minus a plus 3 less than or equal to 0 is satisfied. There is a typing mistake again. 538. Let me note down. 538. So I have started taking down the notes for typing mistakes because I end up forgetting at the end of this. Okay, so we have to satisfy, it has to be satisfied for real x. So we let y is equal to 2 to the power x, given equation becomes y square minus ay minus a minus 3. So for at least one y greater than 0, because for real x 2 to the power x would be greater than 0, that is y will be greater than 0. So we get discriminant as a square plus 4 into a minus 3 is equal to a plus 6 into a minus 2. And when discriminant is less than 0, uh, so we have got here two roots, minus 6 and 2. And when discriminant is less than 0, for all real y, discriminant would be 0. That implies that y square minus ay minus a minus 3 is not less than 0 for any real y. Now, we see that y square minus ay minus a minus 3 is equal to 0 for y is equal to a by 2. So, for a is equal to 2, y is equal to 1 is an acceptable solution. When discriminant is greater than 0, a is less than minus 6 and a is greater than 2. So combining all this, we see that minus 2 to infinity is an acceptable solution for a. Now we come to question 539. We have to find the values of x which satisfy the inequality x minus 2 by x plus 2 greater than 2x minus 3 by 4x minus 1. So we bring everything to one side and we take LCM. We get x minus 1 into x minus 4 by x plus 2 into 4x minus 1 greater than 0. This inequality will hold if numerator and denominator are both positive and negative. For both to be negative, we have the condition 1 less than x less than 4 and minus 2 less than x less than minus 1 by 4, which will give us no solution. Because in this case, x should be less than minus 1 by 4 and minus 2. So there is no common range for the two conditions. If you plot it on a number axis, you will find no common x which satisfies both. So for both to be positive, x should be less than 1, x should be greater than 4 for this one. And for denominator, we have x less than minus 2 and x greater than minus 1 by 4. So you combine these two, you get the range x less than minus 2 and minus 1 by 4 less than x less than 1. Now we come to question 540. We have to find the real values of x for which x squared plus 8 mod x plus 4 minus 48 greater than 0. So first we consider x less than minus 4. So the inequality will become x squared minus 8x minus 32 minus 48 greater than 0. That is x squared minus 8x minus 18. So the roots of this would be 4 plus minus square root of 96. But the only valid root would be 4 minus square root of 96. Okay, because x is less than minus 4, but 4 plus square root of 96 would be greater than minus 4. And now we substitute x greater than 4, so the inequality becomes x squared plus 8x minus 16 greater than 0. The roots of corresponding equation are minus 4 plus minus square root of 32. Again, we discard the negative root, which is the less than 4. So the valid root is minus 4 and square root of 32. So we have got two roots, 4 minus square root of 96 and minus 4 plus square root of 32. So we combine both of them and we find the range as minus infinity to 4 minus 4 square root of 6. This 4 square root of 6 is basically square root of 96. And 32 is basically, 32 is 4 root 2. So you got a union of both that. This is the set notation for range, okay? Union means you combine both the values. 541 says that find the values of x such that log of x square minus 2x minus 2 less than or equal to 0 where base is 10. So for logarithm to be valid, x square minus 2x minus 2 have to be greater than 0. Okay, so the roots would be plus 1 plus minus square root of 3. So x should be either less than 1 minus root 3 or x should be greater than 1 plus root 3. Now our given inequality is this, right? So we take antilog, we get x square minus 2x minus 2 less than or equal to 1. So x square minus 2x minus 3 should be less than or equal to 0. Now this equation has two roots, minus 1 and 3, and therefore x must lie between these two roots. So from here and here, we get the condition as minus 1 less than or equal to x less than 1 minus root 3 or 1 plus root 3 less than x less than 3. Now we come to 548. If x is real, show that. So 542 also has a typing issue. Let me note down. Okay. So our numerator is x minus 1, x plus 1, x plus 4, x plus 6 plus 25 by 7x squared plus 8x plus 4 greater than or equal to 0. It's a very straightforward problem. This is 542, right? Yeah. So discriminant of the denominator is minus less than 0. So discriminant will be always positive because percent of x squared is positive. Now this should be greater than 0, and we have found that the discriminant is always positive. Sorry, denominator is always positive, so our numerator should be also positive. So we rewrite the numerator as, so what we do is we multiply first two terms here and last two terms here. So you get the equation x squared plus 5x minus 6 and x squared plus 5x plus 4 plus 25. Now we write x squared plus 5x as y, we get y minus 6 into y plus 4 plus 25, which is y squared minus 22y plus 1. So this would be minus 2y and this would be minus 24. Yeah, so this is y minus 1 whole square greater than equal to 0. And thus both numerator and denominator are positive, so the entire expression would be always positive. Now we come to the last problem of the set. Prove that for all real values of x and y, x squared plus 2xy plus 3y squared minus 6x minus 2y is greater than or equal to minus 11. So we bring everything to one side and rewrite the equation in terms of x. So x squared plus 2y minus 6 into x plus 3y squared minus 2y plus 11 greater than or equal to 0. Now this is a quadratic equation in x. We see that coefficient of x squared is 1, so the discriminant must be less than 0. So we compute the discriminant. It is 2y minus 6 whole square plus, minus 4 into 3y square minus 2y plus 11. So we simplify, we arrive at negative of, there should be negative of this, okay? A minus sign is missing. Again, let me note down this. So this is, oh sorry, minus sign is not missing. We have switched the sign of inequality. Here it is less than 0, it is greater than 0, so minus sign is taken care of. So we get y plus 1 whole square, which is always true. That is, y plus whole square is greater than or equal to 0. So with this, we come to the end of penultimate set of polynomials and theory of equations. I hope you are enjoying this series and finding it useful. I wish you all the very best for your luck, for the exams and all. Let me show you how you can download the book. You go to my website ashtavakru.org, and you can download the PDF here. As I find typing mistakes and correct them, I upload the new file. This date will indicate that on what date the PDF was updated. So this is, I believe, yesterday, 14th April. And you can also download trigonometry book, so which was updated in January. It is complete, so you can go ahead, download and study. Anything else? So keep practicing, because maths is all about theory. Study the theory, understand the theory. Without theory, you can't solve problems. But your brain won't develop just by reading theory, and the solving problems will give you confidence and reinforce the theory. How to apply theory, the application of theory is very important in mathematics. If you don't do that, you will go nowhere. So with that, I will end this video, and I'll see you tomorrow in the next one with the last set of problems. That is question number 544 to 554. That would be the last set on polynomials and theory of equations, and then we will move on to permutation combination. So thanks a lot for watching the video. Enjoy.